Page 10. So the first problem says the profit P that a firm makes per day can be modeled by the function blah, 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 where N represents the number of goods sold per day. Yay, business problem. Find the maximum profit and the value of N when this occurs. Okay, so this is pretty straightforward. They don't even ask us to find the derivative. All we need to do is type it in the calculator and find the maximum point, right? So I'm going to type it in the calculator. Be back in a second. So there's my function. I replaced all the n's with x's, right? That's it. Then I'm going to graph it. Remember that my x scale is 0 to 100 and my y scale is like 0 to 500. Apparently that's not enough. It needs to be wider. So let's make my x scale into like 1,000. So 0 to 1,000. And then my y scale maybe needs even to be more than 1,000. Let's make it into 10,000. All right, perfect. There it is. And now we're just going to find. The only tricky part of this is doing the window, right? Just start with 100. If 100 is not big enough, go to 1,000. If 1,000 is not big enough, go to 10,000, etc. So we're going to find the maximum. We're going to move the cursor to the left side of the peak, hit enter. We're going to move the cursor to the right side of the peak, hit enter, and then we just hit enter a third time. There it is, 180.978. That would be about the same as 180.98, right? So we'll say n is 180.98. If we only want three significant figures, though, that would be 181, right? And the y value, which is the profit, is equal to 2700.29, and we want 2 decimal places because of cents, right? So this would be a dollar amount, and that's it. So when you make 181 parts, you get $2,700 in profit. Okay. Last one for page 10. So this is another one of those difficult problems that maybe they're going to ask you on the IB exam. I hope not. I'm not going to ask you on the unit exam, but if you want to get above a 4, you should try to figure out how to do these problems. Okay, so I drew this picture. Basically what you do is you have a piece of cardboard, and you're going to cut the corners out of the cardboard. By cutting the corners out of the cardboard, you have a T-shaped piece of cardboard, and then if you fold the edges up, you can make an open box out of it, right? So they tell us that the size of the original piece of cardboard is 20 by 24, and the amount or the squares that we're going to cut out, we don't know what size they are, but they're asking us what's the best size of square to cut out of the corners so that you get the biggest volume of box possible, okay? So how do we do that? So we know that when we fold it up, we're going to have like the volume equation of the box, right? Remember, volume is length times width times height, okay? And in this case, the height is x. Does that make sense? Because like when we cut out these little squares, each square has x length, x width. When we fold it up, do you notice that like each one of these little sides is x long? So then the height is also x. Okay, so the h is actually going to be x. Oops. The h is going to be x. And then we don't know what the length and width are yet. Okay, that's the volume. But we can kind of see that the length and the width of the box are related to 24 and 20, right? Do you see the length of the box is like this part of the box? So that would be 24 minus x minus x. So the length of the box is 24 minus x minus x. The width of the box is like that, right? So that would be 20 minus x minus x. So it would be 20 minus x minus x. And that would be multiplied times x. So there's our equation. The volume is equal to 24 minus x times 20 minus x times x. Okay, so that's the volume of the box. If I wanted to simplify it, I could put minus 2x instead of minus x minus x. It's a little bit more compact. Now I have a volume equation. Find the volume of the box in terms of x. I've done that. There it is right there. Then it says find the x in the volume, find the x which makes the volume maximum, and find the maximum volume. This is just going to be a calculator problem, right? So I'm just going to type in this expression into the calculator and find the volume. Hold on one second. Okay, I just typed it in. The window, remember, goes from 0 to 1,000, 0 to 10,000. I think this is a little big. Let's go back to 0 to 100 and 0 to 100. Okay, let's try to graph that now. Okay, it's a little narrow and a little too tall. So let's at least make it less tall. Or no, it's not too tall. It is too tall. So let's make the grid taller. So we'll put like 500. Still not tall enough. So now we'll do y equals 1,000. Y max is 1,000. There we go. Okay, so we want the maximum point right there, right? Second calc. Second calc. Maximum. Move the cursor to the left of the peak. There we go. To the left of the peak, hit enter. Go to the right of the peak, hit enter again, and then enter one last time. The x value is 3.62. And the y value is 774. And we're done. Okay? Now, is this a hard problem? The part of the problem that's hard is figuring out what this equation is. Once you have the equation, and usually in the exam, they're gonna later give you the equation in case you didn't get it, and they're gonna ask you, okay, now what's the maximum volume? And then you just do second calc max and you're done. Okay? So not too hard. That's it for page 10.